Okay, so we're going to practice naming ionic compounds. This is what we're working on in class. We're going to do the dot notation first and show you how to translate that into the little cross multiplication. Not cross multiplication, the little cross thing that we were working on yesterday, how to do this quickly. So we're going to start with something easy with magnesium oxide. And oxygen has 6 valence electrons, magnesium has 2. The way to use those all up is you take both from magnesium, you put them into oxygen, you end up with magnesium 2 plus, and then oxygen 1, 2, 3, 4, 5, 6, 7, 8 with a charge -2. Or we can do this faster to figure out what our formula should be. Oh, let's jump back a step. So that means the formula unit for magnesium oxide is MgO, because we needed 1 magnesium and 1 oxygen in order to make this work. Now the faster way to do this is magnesium, then you write what the charge of a magnesium ion is, and then oxygen with the charge of an oxygen ion, and then draw an arrow down, and then write it, Mg2. Then you drop that one down, you end up with O2. Now this isn't in its simplest form, simplest terms, so reduce, that comes from math. You end up with Mg. You end up with 1 and 1. They're exactly the same. So you can either do it with the dots or the fast way like this. Okay, now we'll do a few others where the shortcut really saves you time. So let's pick something like lithium and phosphorus. Now we can go through and we can do the dots to balance this, or just write the charge of lithium forms a +1, and phosphorus forms a -3. So start here, drop that down, you end up with Li3, and then it's just a 1, so it's Li3P. So again, you can either go through and do the dots, or you can just write this down, drop that down. Do a few others. Let's do barium fluoride. So again, write your charge. Barium is +2. That comes off the periodic table. Look for the group. It's in group 2. It's an alkaline earth metal, so it has 2 valence electrons. It wants to get rid of those 2, which means it has a charge of +2. Fluorine has 7 valence electrons. He wants to pick up only 1, so his charge becomes -1. So drop him down. That's a 1 right there, so it becomes barium just with a 1, so don't write anything. Then you drop that guy. You end up with F2. So for every 1 barium atom, we need 2 fluorine atoms to make a barium fluoride molecule. And where it comes in really handy is for things like aluminum and sulfur. Aluminum has a charge of +3. Sulfur has a charge of -2. End up with Al, and then use this 2. Then S. Use this 3. So instead of having to go through and figure out, okay, aluminum has 3 dots, sulfur has only space for 2, so move 2 over, and oh, we still have 1, okay, add another sulfur, oh, now we need 2 more. Instead of doing all that, do it with the little crosses. It's a lot faster. Okay, now when you're naming the cation, the metal, the positively charged ion, it's real simple. It's just the name of the element. So again, we did this example in class yesterday, but we'll use NaCl, table salt. It's the most common ionic compound. But look this up on the periodic table. That's just sodium. And that was the anion, your positively charged ion. Then chlorine. Rather than saying chlorine, we use the nomenclature, there's your vocabulary word, to know that it's negatively charged by changing it from chlorine to chloride. And remember, there's those 8 different atoms that we're going to be using for ionic compounds that form those anions. So check your notes and check for these 8. There are chloride, fluoride, iodide, bromide, nitride, oxide, phosphide, and sulfide. Make sure you know that for your test, because calling it sodium chlorine, not going to get you credit. Sodium chloride will get you credit.